right, so I'm here to talk about the future of AI for code, specifically why we think that an open code knowledge graph is going to be important for making AI more useful in a lot of different situations. So quick poll, a show of hands. How many here are using AI code completions today? Okay, cool. Maybe like 60%. What about AI chat for coding? You're sort of like ChatGPT. Oh, more. Seems like people are a fan of the kind of like explicit instructions. How many use neither? Okay, a good showing. For everyone, just shout them out. What are your most common frustrations with code AI? Usually a little wrong at least, right? Sometimes very wrong. Yeah, exactly. And it's really frustrating when you're like, I can trust you, and then you do stuff and then end up wasting a bunch of time following the wrong direction. So that's what the talk is going to be about. Like, how can we solve the #1 problem with AI coding assistants using a knowledge graph for code? A bit about me. My name is Beyang. I'm the CTO and co-founder of a company called SourceGraph. We're a developer tools company. SourceGraph started its journey as a tool for human developers to search and grok code across large code bases and complex code bases. So we like to say we make working in large code bases tractable. And part of how we do that is we built a knowledge graph for code and make that accessible to humans as you're searching and trying to understand existing source code. So what does that mean? Here's the search interface. So, let's say I'm trying to find stuff in my code base. Let's say, I'm trying to find all the squirrels in my code base. So I can go to the SourceGraph search panel. I can search for squirrel, and it shows me all the symbols, all the files, all the kind of entities in code that relate to my query. And then from there, this is where the knowledge graph comes in. It's not enough to just show me the source result. What I like to do as a developer is I like to jump to definition, find references, and basically walk the reference graph of code a lot to build up a working understanding. And so here you can see, you can find references to one of the methods on the squirrel service in my code base, see kind of examples across all the code of how that's used, and also pull history to see who's changed this particular method recently. Now, what does that have to do with AI? That's just a search interface. Search is old news, right? Now we're living in the age of AI. Well, it turns out the code knowledge graph that we built actually is a really good context provider for large language models and other forms of AI, and it actually helps generate much better things like completions, question answering, natural language code generation, and eventually, some semblance of agentic actions in code. So code AI today, there's basically two interfaces that are incredibly popular. Oop. Lose the connection here. Okay. So we got inline completions, and then we got chat, right? Those are the kind of like two most common interfaces that people use AI for coding today. And let's go over each of them. So here's an example of me using ChatGPT. I want to know how to use the SourceGraph API to fetch those references that I showed you earlier. And ChatGPT is more than happy to oblige. It generates some beautiful GraphQL code that queries for the references. And this looks very plausible. But there's one problem. And that's there's a hallucination here. It's lying to me about a particular part of this API. It turns out there is no references node in our GraphQL API that takes a query parameter. This one weird trick will make this work a lot better. And that's if I go and find an example of using the API that already exists. It doesn't even have to be in the same language. Here it's use of the TypeScript API. And I just say, here, ChatGPT, here's an example of me calling this API. Now go generate the response. And then when you do that, the generated response is much more precise because it's anchoring to existing usage examples. So much like a human developer can take advantage of usage examples, whether you're pulling them from Stack Overflow or the find references capability of SourceGraph or your editor, an AI coder benefits from the same. What about inline completions? So here I'm using a popular AI code completion tool, and I'm trying to write a function. I'm trying to complete a constructor invocation, that new interaction expression. And this tool suggests a plausible completion here. It's telling me, hey, you defined that prompt message variable earlier in the function, so let's try to shove that in as the first argument. But the issue is, if you actually jump to definition on that constructor, you'll see that the first argument doesn't have a type that matches the prompt message variable. Prompt message is a string, and the first argument takes a structured object. And that's a really dumb mistake, right? Like you'd expect kind of your entry-level new college grad programmer to not make that sort of mistake. Again, one weird trick will help make the output of the LLM much better in this case. And all you got to do is you got to find a usage example from somewhere in the code base, paste it in right before your cursor, and then trigger the autocomplete. And then it'll do the right thing. But obviously, none of us here are going to sit down and just like copy and paste all these examples from all over the code base. That's boring and tedious, and we'll never do it. And so what we've done with SourceGraph, sorry, I gave away my punchline, is we've tried to combine the magic of large language models with the kind of code graph context retrieval mechanisms that we built for code search and code navigation, and use that to essentially do the copy and pasting for you and orchestrate this process of finding the relevant information so that the answers you get from talking to LLMs, the code generated from LLMs is much more accurate, much more fits better within the context of your code base. And so there's a test that we've come to call the squirrel test, which kind of hints at the importance of context. So if I go to ChatGPT, oh, gotta log in again, sorry. Okay, so I'm in ChatGPT. And remember earlier when I said I was trying to find all the squirrels in my code base? So squirrel is actually a component in the SourceGraph backend. If you go search through the SourceGraph code, you search squirrel, and you'll find a bunch of references to squirrel. It's a component of how we do code navigation actions, like jump to definition and find references. Now, if I ask GPT-4, what is squirrel? It's obviously going to tell me something like it's a small woodland creature or whatever, right? Now, obviously I would never say that. That's kind of like a dumb thing to ask. What if I said, in the SourceGraph code base, what is squirrel, right? Our code is publicly available, so it should, in theory, be part of the kind of index here. I think the GPT-4 training set was updated recently. Now it goes up to 2022. Okay, so now it's trying to visit github.com and do a bunch of agentic stuff. Let's see. Okay, so in the context of SourceGraph's code base, squirrel appears to refer to a feature or branch related to adding more language support. Okay, so I found a pull request relevant, but this doesn't really tell me the answer to my question. It just tells me that something related to squirrel was merged in. So that's not a great user experience. What if I go to something like, GitHub Copilot? They just announced a chat GA that's due out in a couple of weeks with some, workspace level awareness. Now if I go here and ask, what is squirrel? Okay, it tells me squirrel is a high-level imperative object-oriented programming language. That's also not the answer I'm looking for. Now, what if I ask it specifically, hey, take into account the code that I have open in the editor? It's going to do a bunch of fancy agent stuff, try to figure that out. Sorry, but I can only assist with programming-related questions. And the kind of references it found using its search capabilities there's nothing about squirrel in here, even though for a human it's trivial. I just go to source graph and I search for squirrel and I get a bunch of references. So now let's go to the source graph interface. We've actually baked in some of the features of Cody into this interface. And now if I ask, what is squirrel? It's going to do some code searches, find references, and it actually gives me an accurate answer. It tells me it's a service that uses tree sitter for fast and precise code intelligence and source graph. It's an HTTP server, and it tells me the main components, and it tells me references to specific files. So I can go and kind of fact check and audit what it's doing. Surfaces the README, which kind of describes at a high level what's going on, and also the backend component here. And then from there, I can drill in and as a human, kind of like do my thing with find references and walk in the code graph. So that's why we think context matters. Like if you ask a question like, what is squirrel? It makes the whole world of difference how good your context quality is. And there's going to be a lot of people that say they have great context, but to us it feels like a question of like Alta Vista versus Google, right? At a high level, they're both search engines, but one tends to work much better than the other. Okay, so that was the squirrel test. Okay, what about like creating new applications? So how many people here have heard of v0.dev? It's kind of this like buzzy new thing. Vercel released it. It's for kind of like generating Next.js applications with just natural language prompting. And we thought that was cool, but we thought, what if we took that one step further and instead of just making it about Next.js, make it about, you could use whatever libraries you want. Use natural language to generate a code for different sorts of applications that may or may not use a specific framework. So in this example, let's say I want to build like a simple stock tracking app. I have a library here called Alpha Vantage. It's basically an API that provides stock tick data. And I want to make a React app. And so I tag those into context for Cody. And now I'm going to ask Cody, create a React app that fetches stock tick data for, I don't know, what's a bank, Wells Fargo, using the Alpha Vantage client, then render that data in an HTML table. Okay, so again, with the benefit of context, this kind of like open knowledge graph that we built, we're doing a bunch of searches across the relevant repositories that we've tagged in, and we're generating some code. Okay, so this code looks plausible. Let's see. It's importing Alpha Vantage. It's creating an API client. It seems to be fetching the data, and it seems to be rendering it in a table. But does it actually run? I'm very nervous because I think demos are typically a bit stochastic, and generative AI demos are even more so. But pray to the demo gods and see if this works. Okay. I'm going to paste that in. Okay, we get an error. I expect that. I just got to tag in the dependency. Oh, I exceeded the API rate limit. But you saw it render the table, right? I was playing around with this. Okay, a little round of applause, maybe? That's pretty cool. Unfortunately, I can't do the next demo because I'm at the API rate limit. But maybe I can play this video, which shows kind of like the next evolution. Okay, so HTML table is fine, but what if I actually want to render stuff in a chart? So essentially what I do next is I tag in a React charting library called recharts. Again, this is part of like the open kind of index that Cody has built. And now I'm writing a prompt that says like, hey, create a React app that fetches the stock price for Wells Fargo, transforms it, and then renders it using this charting library. I'm really glad you all saw the HTML table before it hit the API error. Otherwise, you would not have believed me. Okay, so I'm typing stuff out. Okay, it's going to generate the code. I'm going to try to fast forward a little bit so you don't have to watch it type out all the code. Okay, then I'm going to go and paste that in. I need to add the recharge dependency. And boom, now I have the Wells Fargo stock price over the past week. So I think this is another illustrative example of what I view as like the power of context and why we're so excited about combining LLMs with this kind of code knowledge graph that we built. Well, that's all well and good, I hear you say. Like, Beyang, great. You know, there's snazzy demo. You answered a question. You told me about what Squirrel is. You told me how to generate a new application. But, you know, I'm not in the business of writing apps from scratch every day. You know, I work in a legacy code base with many other contributors and a long history of code. What about that example? So just real briefly, you know, Kodi is also available in the editor, VS Code extension, JetBrains extension. We have these things called commands, which kind of map to daily tasks that we find kind of toilsome that we prefer not to do, like generate a unit test or write a commit message. Let's say I wanted to add a new default command to Kodi. So the way I can do that is, okay, I'm going to create a new chat. I'm going to ask, where are the default Kodi commands defined? And like, I could do some code searches here, but it would take some effort. I would have to like generate multiple queries, multiple maybe like regexes and string literals to search for. Another option here is we do have this kind of like fuzzier search. So if I search for something like default Kodi commands, that helps me get to the right file. But chat is cool because sometimes it just gets the right answer. So it's like, hey, you should go to this prompts.kodi.json file. Okay. And oops, forgot to delete this earlier. Okay, so this is the file I need to modify. And now once I'm at this file, I can ask, can you generate commands JSON for a new command that summarizes the current file? So again, it used context to find this file and point out this is the thing that I wanted to modify. Saved me a bunch of time of like poking around and probably a bunch of context switches. And then now it gives me some JSON I can paste in too. So it's calling it doc. Let's call this something different, summarize. Then let's say I don't want the current directory as context. I just want the current file. Let me save that, and I'll run it. And this is obviously a toy example, right? Like, this is not a super useful command. I just wanted to kind of demo the value that this can provide. Like, I want to add a new feature to a code base that I've never added before. And then here's our summarize command. Close this. Oops. And it's going to read the file that I currently have open. Okay, 2 out of 3 ain't bad. There's some bugs that we need to work through here. But you get kind of the basic idea. This points me in the right direction. As a human, I can complete the remainders of the steps. We also do things like, you know, inline autocompletion, if you're a fan of that. So, you know, if I wanted a toString method for one of the types I have, you know, let's say I wanted function, let's see, completion response toString. This is kind of context-aware code completion. So it's taking into account other stuff in the file, but also in the broader code base. Again, so we could generate higher quality generations that actually work. They don't have compiler errors and make sense within the context of your code base. So yeah, that's kind of like the quick demo. Hopefully this entices you to care about the technology behind this. Now let's actually talk about what's happening underneath the hood. So underneath the hood, it's pretty simple at a high level. If you're familiar with retrieval augmented generation, this is basically that, both with a lot of care and attention applied to the details. So the idea is you have whatever interface that you're interacting with code. It might be your editor, it might be source graph, and you're trying to do stuff. You might be asking a question, you might be trying to write code, you might be trying to complete the code that you're already writing. And essentially, what we do is whatever your request, Cody is kind of this open core orchestrator of this process. So the idea is that you're going to touch a lot of data sources and a lot of clients, some of which might be open, some of which might be closed. But the fabric that weaves everything together, we think is kind of like naturally open source. It should be open because there's so many different integration points that you don't want to be constrained to kind of like a single vertically integrated provider. And so what happens is when you do a request, whether it's an inline completion or you ask a question, what we do is we consult the code knowledge graph that we've built, which is a combination of the reference graph that we've extracted from the code, but also plugging in other signals like the Git history. And in the future, we hope signals from other applications, tools across the software development lifecycle, and maybe some tools even outside of it, like chat. A lot of the institutional knowledge in our company is just like someone sent a long chat message, and that'd be great to surface as well. The idea is we fetch the context from that using really good search. We send that over to the large language model and basically have it anchor against those facts to generate the output, whether it's generated code or an answer to the question I'm trying to answer. We send it back to the intelligence graph to do some post-processing, catch common hallucinations, do some fact-checking, maybe enforce open source license requirements. If I'm using a model that was trained on non-permissively licensed open source, flagging that and either removing it or indicating that to the user they need to attribute that properly. And then we send the response back to the user. It's all very simple, but the details, there's a lot of work in the details. We think context matters a lot. So if you compare Cody against your average AI coding assistant, the first thing that we think differentiates us is model choice. We're not constrained to a single proprietary language model. We can use the best model for the job. And what we've discovered is, in some cases, the open source models are actually best in class. For example, for inline completions, from our kind of early studies, StarCoder seems to be the best at inline completions, especially with the benefit of context. If you look at completion acceptance rate, which is kind of like an objective-ish metric, basically if you show the user a completion, what's the likelihood they accept it? The leading kind of proprietary coding assistant gets you to 30% acceptance rate after 3 or 4 months of use. So at that point, you've kind of learned what the common hallucinations are. With Cody, we're seeing 30% acceptance in kind of like the first 2 weeks of usage. And this is even before we've integrated kind of like the full knowledge graph. Completion triggers. We are more language aware. Having built this code knowledge graph out, we're kind of experienced in this process of like parsing language and figuring out what the key entities are. And that helps be much more intentful about what you're actually trying to do when you're typing out code. We know if it's like an open function block, in which case you might want to generate a complete function, versus you're just trying to complete an expression where it might be better to go line by line. Context scope. So rather than just taking into account your recently opened files or using kind of like naive vector search, we're trying to build this kind of like multi-index code search backend. And one of the realizations that we've had working in this space is kind of like very anti-hype. It's like the classical information retrieval techniques like BM25 and keyword search actually work very well, especially when coupled with kind of a deep understanding of the code at like a parser level. We're combining that with kind of embedding search and other signals, and we feel that that yields a much better result. Again, everything comes down to context. Both AltaVista and Google are search engines, but what matters is how well they are at fetching relevant data and presenting that. In this case, not to a human user, but to kind of like an AI coding assistant. And then, of course, we think the most important thing here is that we have an open core model. So again, not everything about how the system works is open source. I mean, certainly we still use closed source models like GPT-4 and Claude. But we think the fabric that weaves everything together, that does the coordination, ought to be open, because as more and more integration points become available into this kind of like AI automated software development lifecycle, we don't want this to be kind of a vehicle for tying and constraining everyone to a single vertically integrated ecosystem. And so, you know, the ultimate goal that we're working toward is we're trying to automate all the toil out of the SDLC. You know, when you think about how you spend your time day to day as a developer, I feel like oftentimes like 80, 90, maybe even 95% of my time is spent on like toilsome tasks. Like, I know this code, it's not rocket science, but I have to go in and kind of like read a bunch of files and try a bunch of things before understanding what I need to do. You know, if I'm trying to solve like a security issue, I have to go and do the tedious task of making the same simple change in like a bunch of different places. That's what we're trying to do, and we think the right approach is by combining the magic of large language models with the benefit of the code knowledge graph. And so that's what we think of as the future of AI in code, and we also think that future should be more open than closed. So yeah, that's the end of my talk. Any questions from the audience? Or are we taking questions, or? Okay, cool. Ah, yes.
Hello. If you have a very large project with lots of files, how do you limit the context?
If you have a very large project with lots of files, how do you pick the context?
How do you limit it?
How do you limit the context?
Yeah.
Oh, are you saying because like large language models have a limited context window, you can't shove the entire project in there?
Correct.
Yes, so the approach to that is basically to treat it as a generalized search problem. So instead of just like saying, here's the entire code base as like the input context and then answer this question, which is like slow and expensive, and also we found like less good than first doing like a search. So basically like as a human, if you're trying to answer a question or generate some code, you wouldn't read through the whole project. You would probably do some search queries, find things that you think are relevant, and then page those relevant results into kind of like the working state of your brain, and then do the task that you wanted to do. And so like our approach kind of mirrors that. It's like find these pinpoints in the code base that are relevant to answering the question or completing the task. And then with that small but very precise set of context, have the model generate its output.
Hey, thank you for the talk. What are your thoughts on this closed loop with respect to debugging? That's also a pain point that debugger engineers go through.
Sorry, what are my thoughts on the closed loop?
What are your thoughts on leveraging RAG for debugging?
Sorry, it's very hard to hear with the echo in here. Can you just like shout it?
What are your thoughts on leveraging retrieval augmented generation for debugging?
Leveraging something for debugging?
Yeah, RAG for debugging.
Oh, leveraging RAG for debugging. Oh, yes. So one thing we haven't integrated yet is debugger output as a context provider. That's probably, we should probably do that soon, because like that's highly relevant, especially when you're in the inner loop. But yeah, like that's a great idea. Integrating compiler output and debugger output into the code generation process is something we definitely want to do. The core kind of Cody orchestration stuff is open source, but we do have some context providers that are closed source. Gotcha. Yeah.
I think for next questions, the speaker table outside, table number 2.
Cool. Thank you.